Hi, this is Aves from RIS. We are going through chapter number 5 as a crash course, and we are trying to take a rush through the Federal Board reduced syllabus. And we had previously covered topic 5.1, 5.2, 5.3, and did a basic understanding of all those topics. Now we're going to do the examples. The first example is actually example 5.1. Right, and example 5.1 states that two lead spheres of masses 1000 kilograms, let's say this is M1, this is M2, their masses, let's write the data. M1 is equal to 1000 kilograms, right, and M2 is also 1000 kilograms. Two lead spheres which are 1 meter apart. They are separated by a distance of 1 meter. So we're going to take capital R being 1 meter. Find the force with which they attract each other. What would be the force of gravity between them, right? Or force of attraction. So solution, let's get to the solution. As we do know from Newton's law, of gravitation, F is equal to capital G M1 M2 over R square, right? This force is going to be 6.67 into 10 to the power minus 11. Mass would be 1000 into 1000 divided by 1 squared. Since these units are all in SI units, we're not going to change anything. So the force will turn out to be let's get the calculator on. Let's calculate. That's going to be 6.67 exponent minus 11, right, multiplied by 1000 multiplied by 1000 and divided by 1 squared. So it turns out to be 6.67 into 10 to the power minus 5 newtons. Now this is a very small force. Even your a pinky finger can apply a lot more force than this, right? So that is the very reason these two objects will not be getting attracted to each other. They won't be pulled towards each other. Why? Because there would be so many forces, like forces of friction. Let's say if they're on ground, the force of friction would be far more greater than this force of attraction between them. So you won't get to see them move towards each other like you get to see two magnets that move together. For example, this is north, south, south and north. They will get attracted a lot more easily than these two lead spheres, which are 1 meter apart, not a very long distance. So the force is bigger only because this R is 1. It's not in a negative value. That means it's not that very large, so that the force is having a very lesser negative value over here. Usually this is much larger if the masses are lower or they're separated by a larger distance. So magnetic forces, on the other hand, are not as strong as gravitational. Magnetic forces are far more stronger as compared to the gravitational forces. That is the very reason we have 10 to the power minus 5, right? I mean, your pinky finger can apply up to like maybe up to like 10 newtons, 5 newtons of force. This is however 5 zeros less than that. So you can imagine this is a very little force. Okay, this is example 5.1. I hope you've understood. Let's move on to example 5.2 now, right? Example 5.2. Now, in example 5.2, the question wants us to calculate the value of G at an altitude of 1000 kilometers. So we have height, which is 1000 kilometers, right? And the radius of the Earth, you should remember this, you should memorize this, 6.4 into 10 to the power 6 meters, and mass of Earth is 6.0 into 10 to the power 24 kilograms. You may not write this zero, it's to be very honest, it's significant, but it doesn't really matter for your case. So this is the data. Let's solve. As we know that G is equal to capital G ME over RE squared, right? And we currently have certain height. For height, we would change this formula with, let's rewrite over here instead. We will change this formula by incorporating the height as well, right? So capital G is going to be 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6. I'm going to write this as, this is 1000 kilometers. We need to convert this into meters, so H is going to be 1000 and 3 more zeros, I guess, right? Meters, which is 10 to the power 6 meters. So we will have 10 to the power 6 as well added to it, not multiplied. So that would add 1 to it. So it's going to be 7.4. So G is going to be round. If you calculate this, 6.67 exponent minus 11 multiplied by 6 exponent 24 divided by, and this has to be added, 1 power 6 added to 6.4 to the power 6. Let's solve this. It turns out to be, so our answer is 7.30 meter per second square, right? So this is what we're going to get as an answer. I hope you are able to redo this example on your own without looking at the solution. Just take the equation and then do the calculation on calculator yourself, and you'll be able to solve this. Now moving on to our numericals, and I'm going to simply give a fast solution to it without explaining anything, right? I hope you'll be able to do those on your own as well.